Compare and contrast the graphs of y equals f of x and y equals f at the opposite of x for various functions. And we're going to investigate whether functions are even, odd, or neither. This is part of the family of functions series. You will need graph paper, or you can download this PDF and print it. Press pauses anytime needed during the videos. Let's begin with the function y equals f of x, which equals x squared. We want to graph y equals f at the opposite of x, which is the quantity of the opposite of x squared. Let's make a table. So we have 3 columns in this table. We'll start with our 7 normal values for x. But notice we have to take the opposite of those values and then square them. So we'll do that one at a time. So when x is 3, we're going to square the opposite of 3, negative 3. And when we square that, we get 9. And when we plot the ordered pair, 3, 9, 3, 9. When x is 2, the opposite's negative 2, and we square that and get 4. So 2, 4. 1's opposite's negative 1. Square that, positive 1, 1, 1. And then 0 squared is 0, so the origin. The opposite of negative 1 is positive 1. Squaring that, you get 1, so negative 1, 1. Opposite of negative 2 is 2. Square that, you get 4. Negative 2, 4. And finally, negative 3, 9. Connecting the points. This is the graph of y equals the quantity of the opposite of x squared. But hey, this is exactly the same as graph as y equals x squared. You see that? You see that? So x squared is exactly the same as the quantity of opposite of x squared, which means that f of x is exactly the same as f at the opposite of x. And this is true for all values of x in the domain of the function. When a function behaves this way, we say that the function is an even function. That is, if f of x is equal to f at the opposite of x for all values of x, then f is called an even function. That's the definition of an even function. So y equals x squared is an even function. Let's investigate other parent functions and evaluate at f at the opposite of x. So we'll look at the cubing function, and we want to graph y equals f at the opposite of x, which is the opposite of x, the quantity cubed. Again, we'll make a table with 3 columns, and these will be our 5 values that we'll start with. We need to take the opposite of them, as you can see there in the parentheses, and then evaluate that opposite cubed. So when x is 2, its opposite is negative 2, and when you cube it, you get negative 8. So let's plot 2, negative 8. X is 2, y is negative 8. When x is 1, the opposite's negative 1. Negative 1 cubed is negative 1, so 1, negative 1. The origin remains the same. The opposite of negative 1 is positive 1. Cube that is 1, so negative 1, 1. And the opposite of negative 2 is positive 2. When you cube positive 2, you get 8, so negative 2, 8. Graphing that, connecting the points, this is y equals the quantity of opposite of x cubed. Hey, this is not the same graph as y equals x cubed. Graph of y equals x cubed looks like this. However, it does look familiar. Remember what that looks like? Here's a graph of y equals the opposite of x cubed in a brown dashed graph. Y equals the quantity of negative x, or opposite of x cubed. And you can see that those are identical. Y equals f at the opposite of x, and y equals the opposite of f at x. Negative signs in both of them, but in different places. So the opposite of x cubed is equal to the quantity of the opposite of x, and then cube it. 2 different things. But in this case, they have the same looking graph. So f at the opposite of x equals the opposite of f of x. Again, the negative sign's in a different spot. This works for all values of x. So when a function behaves this way, we say the function is an odd function. That is, if f at the opposite of x equals the opposite of f of x for all values of x in the domain, then f is an odd function. That's the definition. Y equals x cubed then is an odd function because it behaves this way. Let's investigate another parent function and evaluate that at f at the opposite of x. Here we're going to look at y equals f of x equals 2 to the x power. And we want to graph y equals f at the opposite of x, which would be equal to 2 to the opposite of x power. Again, we'll make a table, 3 columns. These will be our 7 values of x that we want to use. We need to take the opposite of x because that's what's in the exponent here on the one we want to graph. So when x is 3, the opposite is negative 3, and we're going to take 2 to that opposite 3 power. And that's going to be 1 over 2 cubed, which is 1/8. So 3 comma 1/8 is plotted first, 3 comma 1/8, xy. When x is 2, y is equal to 2 to the opposite of that 2, which is negative 2. And that's 1 over 2 squared, which is a fourth, 2 comma a fourth. X is 1, the opposite's negative 1. Y is equal to 2 to the negative 1 power, which is the reciprocal of 2, 1/2, 1 comma a half. 0, the opposite of 0 is 0. 2 to the 0 is 1, so 0, 1. The opposite of negative 1 is positive 1. 2 to the first power is 2, so negative 1 comma 2. Negative 2 comma 4. And negative 3 comma 8. Press pause if you need to catch up. Connect the points. And we get this graph right here, y equals 2 to the opposite of x. This is not the same graph as y equals 2 to the x. We'll graph that on the same pair of axes. Notice that the x-axis is an asymptote for both of them. So y equals 2 to the x is not an even function. It's not the same as the graph y equals the opposite of 2 to the x. Let's look at that one as well. This is y equals the opposite of 2 to the x. These are not the same. And since they're not the same, then this y equals 2 to the x is not an odd function either. It's not even and it's not odd. It's neither even nor odd, so it's called neither. It's neither even nor odd. Some functions are even, some are odd, a lot are neither. So let's summarize that. Here's the graph of y equals x squared, and the graph of y equals the quantity opposite, x squared. You can see they're identical, so this is an even function. F of x is equal to f of the opposite of x all the time. Here's an example of an odd function. Y equals x cubed is odd because the graphs of y equals the opposite of x cubed in brown and y equals the quantity of the opposite of x and then cube it in green are identical. So f at the opposite of x equals the opposite of f of x. This is called an odd function. And then here's one that is neither. Y equals 2 to the x. Blue is the parent function. Green is the f at the opposite of x. And here the brown is opposite of f of x. All very different. This function right here, y equals 2 to the x, is neither. Press pause as needed. Let's use TI-Nspire technology to investigate 4 more parent functions. For each graph y equals f of x and y equals f at the opposite of x, and decide if the function is even, odd, or neither. Let's investigate the graphs for y equals f at the opposite of x for these 4 different functions here. So we'll go ahead and proceed to the next page. And on this page there's a slider that has us be able to click the slider to go on to the next step. So the first step is to show we're going to graph y equals the absolute value of x in blue. And so this is its graph. We're going to graph y equals f at the opposite of x is a red dashed function. And you can see that those two are identical. So is this blue function, which one? It is an even function because f at the opposite of x is exactly the same as f of x all the time for all values of x in its domain. So the absolute value is an even function. Press pause at any time. The reciprocal function, we'll graph that in blue. F at the opposite of x, which is 1 over the opposite of x, is going to be red and dashed. And you can see those are not identical. So this is not an even function. To check if it's odd, we'll graph y equals the opposite of f of x, which is the opposite of 1 over x. That's in green. And you'll notice that the green and red are identical. Again, okay, they're identical here. So since f at the opposite of x is always equal to the opposite of f of x, we call this an odd function. The reciprocal function is odd. Next one, f of x equals the square root of x. Let's graph that in blue. Y equals f at the opposite of x, the square root of the opposite of x. That's graphed in dashed red here, and you can see those, it's not even, those are not the same. This is not an even function. So we're going to go ahead and graph y equals the opposite of f of x, the negative square root of x, and you can see that here in green. And none of these are equal, so the function is not odd either. So since it's not odd and it's not even, it's neither even, or odd. And the fourth and last one is a generic function that I made up, y equals f of x, this blue function right here. We're going to graph y equals f at the opposite of x, red dashed. And you can see those are not the same, so this is not an even function. We'll also graph y equals the opposite of f of x and do that in green. And you can see that it's a reflection about the x-axis with the blue. None of these are the same, so the function's not even, it's not odd, it's neither even nor odd. So let's summarize what we just saw in TI-Nspire. Here was the first one, y equals the absolute value of x. You can see that f of x and f of the opposite of x were exactly the same, so this is an even function. Press pause at any time as needed. Y equals 1 over x, reciprocal function. You can see that f of the opposite of x and the opposite of f of x are identical, so this is an odd function. The square root function was neither. You can see that it's definitely not even, definitely not odd, so it's neither. And this piecewise function that I created in blue here is not even, it's not odd, it is neither. Now you try one by hand. Graph y equals the square root of the quantity 25 minus the quantity of the opposite of x squared. Decide if this function right here, the semicircle function, is even, odd, or neither. Press pause to do this and then resume when you're finished to check your answer. And here's the answer. And you'll notice that both of these functions right here are identical. And since f at the opposite of x and f at x are exactly the same for this particular domain, it is an even function.